Let's get it
All
going.
right. Do it.
All right. Now, as everybody remember, last week we got into this, and uh, we were just sort of talking about if you we talked about where you have listed loads or listed occupancies and unlisted occupancies. So just say you don't have a listed occupancy here. Basically, I'm just going to give you some loads here, and here's how you would calculate it. And I said when you do this, you'll remember I talked about this. I said you could go over and when you were looking at the calculation, and you could go look at 210.19A1A, you could, and B, and then you could also look at 215.2A1, and then also look at 230.42A1A2. All of
Okay.
those are the same. And basically, all it's telling you is if you have a non continuous load, you take it at 100%. And if you have a continuous load, you take it at 120. Okay.
Right.
Looking at the illustration, this is very simple. I've got 70 amps here, a non-continuous load, and I've got 90 amps, a continuous load. So I'm just going to come over to my exercise problem, put 70 amps at 100%, 70 amps. 90 amps, it's continuous, take it at 125%, gives me 112.5. If you wanted to, you go look at 220.5B. If you're zero point 0.5 or higher, you could just round it up to 113. But we'll just say it's 182.5, or you could say 182.3. Either one of them works for me. Okay.
Yeah, I don't know about that luminaire on the end, man. That I don't know what they're doing there. That one, it's gonna need like an all thread or something like that. That one.
It's just showing you a luminaire. We're not trying to go in depth on it.
I know. I'm just kidding.
Okay, now let's look at 220.12. Now, if you go over and you look at the table, uh, you're going to come over and you're going to be looking for a store area here because this is a listed occupancy and it's going to tell you take it at 3 VA. So all I'm going to do is take the 6,000 square foot at 3 VA, gives me 18,000 VA. Then you'll see a note if all those loads were going to be continuous operating for 3 hours or more per Article 100. I'll take it at 125%, and that'll give me 22,500 VA. Pretty basic. Okay. Now, here's one. I'm just going to show a lot of different lighting units here. I've got electric discharge lighting, I got recessed lighting, and I've got incandescent lighting. Okay. I'm just going to, we'll just say that as you look at the top left hand side of the illustration, we tell you the occupancy is not listed in table 220.12. So therefore, I'm going to have to calculate each one of these. Now, to keep it simple, we're going to tell you if you look at the electric discharge lighting, I've got 16 units at 180 VA. Take that, multiply it together, gives you 2,880 VA. Then if you take and look at the incandescent lighting, we got 12 units at 150 VA each. Multiply that together, gives you 1,800. Then my recessed luminaires, I got 10 units, and each one of them are 100 VA. Multiply that, gives you 1,000 VA. Total that up, gives you 5,680 VA. Now you're going to notice in the illustration, we tell you right up at the top in the middle there, we tell you this is all this lighting here is continuous. So if that's the case, I'm just going to multiply it by what? 125%. That gives me 7,100 VA. Pretty simple.
Right.
Okay.
Hey, question for you. Would that calculation be any different if you have lighting control? Would that not be continuous?
Well, it depends on how it's set up. If
Mm-hmm.
it, because you got to look at the definition. If it's
Right.
operating for 3 hours or more continuous, that's what it really comes down
True.
to. Okay.
Gotcha. Okay.
Now, here's show window. Now, as we looked at this, if you go over and look, we did this the other day. If you look at 220.43A, it tells you that you can take a load of not less than 660 volt amperes or 200 volt amperes per linear foot. The other was linear meter. So we're going to take this show window at 200 volt amperes. So I've got 100 foot here. I'm going to multiply that at 200 VA. That gives me 20,000. We're telling you in the illustration it's continuous. And if it's continuous, we take it at what? 125%. So that'll give me 25,000 VA. Now, just remember, everything that I'm looking at here and I'm doing these calculations, I'm all of this is in Article 220. Okay.
Right.
And we're just taking and getting these values. Now, when I apply the 125%, I'm looking at 210.19A1A, 215.2A1A, and 230.42A1. Okay?
True.
That's where the 125% is coming on for the continuous use. Then you automatically know you look at Article 100 for the definition of continuous duty, and it'll tell you that's any load that operates for 3 hours or more. Okay?
Yeah, and one thing you kind of want to look at too with this is if the question on the exam includes voltage drop, they're not asking you to include that. A lot of times what they do in these questions is they say like the length of it and they try to throw in that voltage drop. That's not part of the exam question. That's just an informational note over there in 210 and over there 210.19, 210.20, wherever it's right in there somewhere.
Well, it
But
depends on which
just
one you're looking at. You're at 210.19A, and then you're also at 215.2A. And that's
right.
where, if you're looking at 19, you're in fine print note number 4. And then if you're in feeders, it's fine print note number 2.
Yeah, but a lot of times they'll throw in that circuit length to try to confuse you and think that you have to do a voltage drop calc. But if they don't specifically ask for it, then they're just wanting you to do this calculated at 100%, 125%, whatever it is to get that overall value. And don't confuse yourself throwing that voltage drop in there.
Well, usually when they do that, where they're going to hit you up on that is going to be if it's a feeder going to another panel board, and they're calculating
True.
all the loads for that. At the service, you don't have to worry about that.
True.
Okay. And then some say, well, what if you're at the service? Well, if you got a disconnect out there and then you're running into a panel board, the first means of disconnect is at that disconnecting means. So that's where you're setting up and knowing how to fuse that. And then from that point coming in, that's a feeder. Okay.
Yeah, and I see a lot of times guys will say, well, if you're going to factor in voltage drop, just go up to the next size conductor. And that's not correct. And a lot of times you'll fail an exam question if you just think that mentality. They want you to know on the exam the exact conductor size. And if they're trying to fool you with different little things, you have to kind of pay attention to that and know they're not trying to get you to go up to a number 8 for like 30 amps or anything like that.
Sure. All right. Now for your lighting track, you're looking at 220.43B, and it tells you when you're dealing with lighting track, this is another than dwelling units or guest rooms or guest suites, hotels and motels. But it'll tell you that an additional load of 150 volt amperes shall be included for every 2 foot of lighting track. So all that means is I'm going to take whatever the length of the lighting track here is. So we're telling you we got 30 foot of non-continuous. So you're going to take that 30 foot, divide it by 2, and then you do it for every 2 foot. So you'll multiply that at 150 VA, and that'll give you 22,500 VA for the lighting track load. Now, if this was continuous, all I would do is have another step is take the 2250 times 125% to get my load. Okay?
Right.
Now, the next one you have is your low voltage, and this is just simple. We're going to tell you, we're giving you the information here. We're telling you what the isolating transformer is set up at and everything. It's at 40 amps. We're telling you it's a continuous load. We're showing you the panel there is at continuous operation. So if it's continuous, take the 40 amps and 125% gives you 50 amps. Pretty simple. Okay?
Nice.
Now, here I'm looking at doing outside lighting. I'm going out to some poles outside. Okay? So I've got 50 units there, and they're 120 volts each, and we're telling you in the illustration it's continuous operation. So all the information is already given to you. I'm just going to take the 50 units at 120 VA. That gives me 6,000 VA. It's continuous at 125%. You get 7,500 VA for your outside lighting load. Pretty simple. Okay?
Nice.
And if you look, that's done just like I was doing my other fixtures inside, wasn't it? I didn't do anything.
Yeah. And this is kind of why I want to bring up like the voltage drop thing, because you could think that some of those light poles are going to be pretty far away, but the when you're in an exam, they don't want you to think about that, because that whole voltage drop calculation is a totally separate calculation. If they're going to ask you a voltage drop calculation, they're going to ask you that specifically for that application. But I know we had some light poles on one of my job sites that were like 1,000 foot from the building, and
let me say something about that. If y'all get into links like that, what you want to do is you want to set up to where you go out so far of a distance, and then from there you can start branching them down. The size of the conductor, it doesn't have to be that size all the way. So you may go 200 foot and get a size, and then you go another 200 foot, then another 200 foot. You see what I'm saying? You do it like that, and that way you can get down to the size. You don't have to pull that full size all the way. Okay.
Yeah, and that's a good point. Thanks for the like. We had a like just pop up. I appreciate you guys smashing the likes tonight. Appreciate it.
Smash them out, boys. All right.
Yes, sir.
Now, for the sign lighting load, you'll be looking at 220.14F, and it also ties in with 600.5A. But basically, if you look at 220.14F, all it tells you is that you have a sign and outline lighting outlet that it's required to be calculated at a minimum of 1,200 VA. When I look at 600.5A, it says you have to have at least one. Okay. So here, I'm going to take it at 1,200 VA. We're telling you it's at 1,200 VA. Now, if this was 1,000 VA, I'd have to kick it up to 1,200 VA. Okay. We're telling you, of course, that sign's going to be continuous. So I'll just take the 1,200 VA at 125%, and that gives me 1,500 VA. Now, if you remember when we started this last week, I said there's 7 loads you have to do. Okay. This is the first set of loads, which is all my lighting loads. The next set of loads we're going to do are receptacle loads. Okay.
Okay.
So now you get into.
Hey, can you go back to that last slide?
Yeah, sure.
Is that out in your front yard? Is that your billboard sign out here?
Right. That's our sign out there. We're telling you the best publications in the industry, baby.
I kind of did a little double take on that. All right, go.
Hey, always in self-promotion mode, baby.
You got it.
That's good. That's funny. All right. Now, when we look at receptacle loads, if you go over and look at 220.14I, you'll pick up your receptacle outlets, and they'll tell you that the receptacle outlets are required here to be calculated at not less than 180 volt amperes for each single or for each multiple receptacles that are on one yoke. Okay. So here's my receptacles. I have to take them at 180 VA. Now, I'm going to show you doing 2 here. These could be continuous or non-continuous. Okay? We're not telling you, we're just going to show you both calculations. So I've got 40 in total. So you take 40 at 180 VA. If they're continuous, I take them at 125%. So 180 times 40, 7,200 VA. Multiply that at 125% for continuous gives you 9,000 VA. If they were non-continuous, you just do it at 100%, and that gives you 7,200 VA. Pretty simple calculation. Okay? Now, what happens if I get over 10,000 VA? Now, if you look at this lesson here, I'm at 9,000, 7,200. I'm fine right here. All right? I'm not over 10,000 here. So now I'm going to do the same calculation, but you need to look at table 220.44 when you're dealing with this. And it's going to tell you the demand factors, and it's for non-dwelling receptacle loads. This is not for dwellings. This would be commercial and industrial. And if you're over 10,000 VA, then whatever's remaining, you can take at 50%. They actually give you a demand factor there. So if I look at 150 receptacles, we're doing these at non-continuous use. Take it at 180 VA. That gives me 27,000 VA. So I'll take the first 10,000 at 100%. Of course, it's 10,000 VA. That gives me 17,000 VA left over, which table 220.44 allows me to have a demand factor of 50% on that, and that will give me 8,500. Just add the 10,000 and 8,500 up, and your total receptacle load is 18,500 VA when I have a receptacle load that exceeds 10,000 VA. Okay?
Hey, I have a question real quick on
Mm-hmm.
that one. Is that 3 or 4 outlets?
Three.
I agree.
Why was there four? Oh, I can see where they would want that. And the thing is, you notice we're saying receptacles there, and then we say receptacle loads. You notice we don't
Yeah,
say receptacle outlets. The reason is because the box is the receptacle outlet. We're not
yeah,
doing receptacle outlets here. We're doing receptacles. Okay.
nice. All
Now,
right.
here's a multi-outlet assembly. We looked at this last week, and if you just look up at 220.14 H1 and H2, it's right above the I there for receptacle outlets, and the heading will be fixed multi-outlet assemblies. And then 1 and 2 is going to talk about where you're using them simultaneously, and one where you're using them non-simultaneously. Okay, so if you look at simultaneous use, I'm just going to take it at 180 VA. So I got 200 foot at 180 VA gives me 36,000 VA. That's my multi-outlet assembly load. But now if there are non-simultaneous use, let's see what it says there. It says where appliances are likely to be used simultaneously, each 5 foot or fraction thereof of each separate and continuous length shall be considered as one outlet not less than 180 volt ampere. So that means I've got to divide that 200 foot by 5. So I divide the 200 by 5 and then just multiply it at 180 VA, and that'll tell you your non-simultaneous load is 7,200 VA. Okay, so it depends on which one you're doing, and you'll notice we'll get into that when we're doing full calculations, and I'm showing the step by step doing all the loads and how to calculate. Now, that takes care of 2 loads. We've done the lighting and the receptacle. The next one we
Right.
get into is special appliance. Okay, so we're just going to give you the load here, and if you just look at 230.42A1, it just tells you if you got the load for the appliance here, just get the VA of the load and then just multiply it 125%. Well, we got 13,728 VA. It's continuous. Take it at 125%. And that tells me my special appliance load here is 17,160. Now, if I look at non-continuous, I take it at what? 100%. Okay, which would be 13,728 VA. Very simple. And one thing I want to point out, if you notice, it hasn't mattered to this point. I've done what? Lighting, receptacles, and I've done special appliances. And I've always looked, do I have a continuous or non-continuous load?
True.
I haven't varied from that. Okay. Just maybe some
Yeah.
variables for like if I'm doing lighting, I got show window, I had to take it at 200 VA. If I had track lighting, I had to divide by 2, then take it at 150 VA. Those are the little things you learn. If I have receptacle loads, if I'm over 10,000 VA, then I can put 50% on any additional VA above 10,000. Those are things that you want to learn as you're going through this. Remember the variables. Everything else is staying the same. Okay.
Nice. We have a question coming in real quick,
Mhm.
James.
Which program? Let
So
me
I
know
think
which
he's
one.
talking. I think he's talking about the one for instructors, for educators, probably.
Those are about to come out by the end of summer. We'll have uh, the the first publications you're going to have is you'll have the Journeyman, uh, and if you're an instructor and you purchase the Journeyman publication, then we'll give you uh, the PDF of just the illustrations, and you can teach from that. If you're doing the generators, transformers, motors, we'll have that. You can purchase the whole book with the present, all the illustrations, or we'll have them individually at that point too. We'll also have just where you can purchase generators, you can purchase transformers, or you can purchase motors, and you can purchase that with just present, or you can or purchase them as individual chapters, and we'll have those also where you because I've talked to a lot of instructors, and sometimes they may be at one point where they're just doing troubleshooting. They want the newest version for troubleshooting, and they'll just purchase the troubleshooting. They may be doing transformers, and they just want the whole thing just for transformers. They don't need the whole book. So they can purchase what they need as they go. And this way, you know, everybody, if you're out instructing, you can go out and do specialized classes just on whatever it is you want. We'll also have one for masters, and then we'll also have different, we'll have 10 different ones on calculations that you can go in and just teach certain parts of calculations that you want. This works out better for the apprenticeships. They can go in and actually teach what they're wanting to teach at that point in each semester. And the publications won't be real expensive because they can purchase them in PDF if they want. And that's much cheaper, and they can have it on their computer and view it during class. So,
Hey, one of the guys out there asked if they can modify it for exam prep, and it says asking for a friend.
No, Paul, you can't do that without. Okay, that's one thing I've got. The publishing company has those locked out where you can't print them or modify them. So, not going to be able to do that.
Right. Dude, how did you know what friend I was talking about? Come on.
All right. I just know. I know who does it, who doesn't. Okay. All right. Now this is the third load, the last one here, where we're going to deal with special appliances, and this is where you're going to get in. And if you go look at table 220.56, I think it's like on page 78 or 79, somewhere in there, and it's going to tell you for 2 units, there's no demand factor; it's 100%. But once you get to 3, you can go 90, 4, you can go 80%, 5, you can go 70%. Anything over 5 is going to be 65%, no matter how many you have. Well, looking at this, I've got 4 pieces of cooking equipment, 2 kettles, 3 fryers, 2 steamers, 3 boilers, and 2 microwaves. So I'm definitely over 6 or more here. And we're telling you right in the middle of the illustration there, we have a total kitchen load that we've already done the calculation for you of 82 kW. Now, if you had to calculate each one of these, all you're going to do is come back and look at it like this. Okay? You just get the VA of it. Okay? So we're telling you we have 16 pieces of equipment. If I look at table 220.56, 6 or more, I can put a demand factor of 65% on that. We're telling you we've already calculated the kitchen load. It's 82 kW. Take that at 65%. That gives you 53.3 kVA load. Put it in VA, just multiply it by 1,000. That's how simple it is. Okay?
Hey, do you want me to tell you some insightful wisdom about that?
What's that?
So if you have 16 pieces of kitchen equipment, you only have 15 outlets. Yeah. You're always short one.
Yeah. Mm-hmm. That's what they want you to believe.
No, I'm saying it's every single time I do a kitchen, I'm like, do you have everything you need? They're like, yep, everything's good. And you're like, all right. And you do it, you get it all in there. And then they're like, where do I plug this in at? And you're like, what? I freaking went over this 7 times with you guys. You're always short one on a kitchen. For some reason, they're like, where do I plug this in at? Well, I'm going to have to run you a dedicated circuit, and then we'll plug it in, you know.
Oh, yeah. All right. Now, I want everybody to remember this. We're getting in here. This will be my 4th load. We're going to do compressor loads, and after this, we'll do our motor loads. All compressor loads and motor loads right here when I'm doing the service calculation, or I got a feeder going over, and I'm doing calculation with all these loads for a panel board and setting it up and everything. You're going to take all these motors at 100%. Then when we get to the last load, which will be the 7th load, then we'll get in and add 25% for the largest motor. Okay? So looking at this, I've got 2 compressors here. I got a 35 and a 45 amp. They're 480 volt 3-phase, so it's very simple. Just take the 35 amps times 831 volts. That'll give you 29,085 VA. Then do the next one the same, which is 45 amps. Take it at 831 volts. That's 480 times 1.732. That'll give you 37,395. just take them all at 100% at that point, add it up. We got a compressor load of 66,480 VA. Simple. That's 4 loads. Okay. What's my 5th load?
Right.
Motor loads. Okay.
Yeah.
Now you're going to see my motor loads. If you look in step 2, I took everything at what? 100%. Okay.
Yeah.
So I'm looking at this. I've got a 10, 20, 25, and 30 horsepower motor. They're all 3-phase, 460 volts. Anytime I'm going to size my overcurrent protection, my conductors, 430.681 says use one of the tables, and 430.247 through 250. In this case, it's 3-phase, so we're going to use table 430.250. Go over there, pick up that table, and when you pick up that table and come down the 460 volt column, a 10 horsepower is good at 14 amps, a 20 horsepower is good at 27 amps, a 25 horsepower is good at 34 amps, and a 30 horsepower is good at 40 amps. Just take them all at 100%. That gives me 115 amps. Then I'll take it by the voltage. 480 times 1.732 for the 3-phase gives me 831 volts. Multiply that by 115 amps. That'll give me a total motor load value here of 95,565 VA. Now, if you notice, it didn't matter if I did the compressors this way or the motors. I did the same thing. Everything was at 100% here. Okay?
I like it.
Now, that brings me to the last thing I need to look at here. My non-coincident load in 220.60, the largest between the heating and the AC. Well, I've got 10 kW of heating unit and 5.5 kW of AC. That's an easy one. The 10 kW is the largest. So you drop the other one. The AC load gets dropped. The largest motor load is 10 kVA. That's 6 loads. Now we have one more to do. What's the largest motor load? So you're looking in here. I've got a 40, 45 amp and a 7 amp here. I can already tell you because we've already done this on the others. None of them in the motor was larger. So I look at this, the largest one, if you look, the 30 horsepower that I have there is larger than the 10, 20, 25 amp. It was only good at 40 amps. The compressor was good at 40 amps. And that's interesting because that's going right back to what we had already done here. See?
Yeah.
I did a 35, 45 amp. Then I did all them motors. Then I brought them over here to the last one to sort of lay it out. And looking at this, the largest is 45 amp. Take it at an additional 25%, gives me 11.25. It's a 460 volt 3-phase. That means I'll multiply it 831 volts, and that'll give me 9,349 VA. That's all you have to do in order to do your full calculation.
I think that's a good point what you bring up, because I think people need to realize how to do that. Like when you go to largest motor, because they'll do that to fool you in the exam, where they'll put 1 in horsepower and they'll put 1 in amps, and you have to know what the 1 horsepower is so that you can multiply it and figure out which one is your largest.
Sure. That's exactly how you do it. And another good in that, the last thing we have here is where I get in and I'm adding additional loads where I have an existing installation here.
Right.
So in this case, I'm going to add a new panel board here, and it's 102 amps. Now, when you go over and you look at this, we did this the other day, but if you go look at 220.87, the heading's going to say determining existing loads. And when you go over there, it's going to tell you certain things you can do here. And it's going to say the calculation of a feeder or service load, which I've been talking about, feeder and service loads, for existing installation shall be permitted to use actual demand to determine an existing load under the following conditions. It says the maximum demand data is available for a 1-year period. Okay, we've done this for you. We're telling you it's 218 amps. That's my recorded amps. Then if I go look at Pren 2 there, it says the maximum demand at 125% plus the new load does not exceed the ampacity of the feeder or rating of the service. Okay, well, let's look here. We're telling you the actual peak amps recorded for a period of 1 year is 218 amps, and we're telling you the service had 500 kc mil. Okay, so it tells me to take that demand by Prin 2 at 125%. So I'll take the 218 amps times 125% gives me 273 amps, and then I'm going to add the additional load on here that I'm adding, which is the panel board load at 102 amps. That gives me 375 amps. Now all I need to do is check if the conductor's large enough. So if I go look at table 310.16 in the 75 C column, come down, pick up the 500 kc mil, come across, it tells you it's going to be good at 380 amps. So that's above the 375 amps. So yes, I can take and add the 102 amp new panel board load to the existing service that's there.
Nice.
Okay, and that
Yeah.
gets us